Good morning. We are going to be doing indicator 17 today. And this indicator, again, it is under unit 5. And unit 5 comprises of indicators 15 through 20. Okay. This one, you can see the learning target. I can compare ratios using tables and find the missing values. And then I can plot pairs of ratio values using a coordinate plane, okay? So these are my learning targets over here. So basically, a table will be given to you, like for example, this one, all right? And looking at this table, first and foremost, you will have to fill the blanks. Fill in the blanks on the table. You have to complete the table. And then using the information on the table, you will do other calculations, okay? So that's basically what ratio representations are. And it's all a ratio. So let's say, because if I say 7 bicycles in 5 minutes, so see how that is a ratio. You have 14 bicycles in 10 minutes, 21 bicycles in 15 minutes. So it is telling you how many are passing in that certain time frame. So that's what makes it a ratio. When we throw in the units, it becomes a rate. Okay, so let's look at this. And Samantha found that 7 bicycles passed her house in 5 minutes. Okay, so Samantha found that 7 bicycles passed her house in 5 minutes using this rate. Okay, remember it's called a rate because you are putting those units in. The bicycles and the minutes makes it those are the units. So using this rate, she made a partially complete ratio table to show the relationship between time and number of bicycles. So the first thing to do is to complete the table. Okay, so I can see there's a pattern going on. Okay, if I look at this table, I can see there's a pattern going on. The minutes are increasing in 5. Okay, and the bicycles are increasing by 7. I can see that, when I see this ratio pattern. So I can see over here I have +5. I can see over here I have +5. I have +5. So when I look at this, I know that this is what the pattern looks like to me. Okay. Over here it is going as +7, and then +7, +7, +7. So this is what it's going to be, comprise. When you look at it, you look at the pattern, and that's going to comprise what the missing values are. Okay, so or 7 times 1 is 7, times 2, 14, times 3, 21. So I know this is going to be 28. Okay, and then if I look over here, 5 times 1, 5, times 2, 10, times 3, 15, times 4, 20, times 5 gives me 25. Okay, so this is how I complete this table. All right, now let's go ahead and solve some other problems. And there are several ways to do this. Okay, so at this rate, how many bicycles will Samantha expect to see over 1 hour? Over 1 hour. Okay, so there are a couple of things I can do. Okay, there are a couple of things I can do. I can either extend this. I can extend this and make it to 30 minutes, and this would become 42, right? Because +7 +7. So once I have 30 minutes is a half an hour. Okay, so in 30 minutes, we have 42 bicycles. All right, based on this ratio. Or let's just put it, if you're writing it as a ratio, you can also write it as 42 bicycles in 30 minutes. All right, so here's my ratio. Now, we know that in 1 hour, we have 60 minutes. In 1 hour, we have 60 minutes. So, I know that to make 60 minutes, I would have to do 30 times 2. Whatever I do to the denominator, I have to do the same thing to the numerator. So then this would become 42 times 2, and I would get 84 bicycles in 1 hour. So this is just one of the ways to do it. I'm just going to show you. I'm just going to remove this. Okay. Well, I could do another thing. I could do 7 bicycles over 5 minutes. And I know that they are 60 minutes in an hour. So I am going to make an equivalent ratio, and because I need my denominator as 60 minutes. Okay, and so I would do, all right, 5 times 12 gives me 60. All right, so 7 times 12 would give me the missing value over here, which is 84 bicycles. Okay, so it doesn't matter how you do it. You can still get the same answer. We can also do, you can take 15. You can do 21 over 15 because this is your minutes. All right, and this is your bicycles. And then you can say this one is equal to, we know that if 15 is a quarter, so 15 times 4 is going to give me 60. Okay, times 4 gives me 60 minutes. And so I can do 21 times 4 gives me 84 bicycles. So there are so many ways to do this. You could have done 20 times 3 gives me 60. And so 28 times 3 is going to give me 84. Okay, so this is how you calculate at this rate. And we're thinking that the rate is the same. All right, that means 7 bicycles in 5 minutes. So at this rate, how many bicycles will Samantha expect to see over 1 hour? So in 1 hour, which is 60 minutes, so in this one we got 84 bicycles in 1 hour. Because remember, 60 minutes is equal to 1 hour. Okay? The next question is asking, at this rate, how many bicycles will Samantha expect to see over 3 hours? Well, we've got what's in 1 hour. Okay, so I'm going to erase this. We've got what, Samantha had seen the rate in, or Samantha is seeing in 1 hour. So in 3 hours, in 1 hour, it was 84 over 1. So 84 bicycles over 1 hour. So over 3 hours, all you're doing is you are multiplying with 3. Okay? Because 1 times 3 gives me 3. Whatever I do to the denominator, I do the same thing to the numerator, and I do 84 times 3. And when I do 84 times 3, I will get 252 bicycles. Okay, so then in 3 hours, I will get 252 bicycles. All right. Then it's asking, at this rate, how many bicycles will Samantha expect to see in 2.5 minutes? Listen to this one very carefully. Okay, in 2.5 minutes. So we have the rate. Let me go ahead and first write this down. For the 3 hours, we had 252 bicycles over 3 hours. Okay, so you can see what I'm doing. And now we're talking about 2.5 minutes. Okay, so let me go ahead and show you that ratio. If I'm saying 7 bicycles in 5 minutes, how many will I get in 2.5 minutes? Okay, now we know that anything half, that's what's going on, because if I do 5 divided by 2, I get 2.5. Okay, so half of 5 is going to give me this. So I'm dividing by 2. So whatever I'm dividing by 2, if I'm doing that here, I have to do the same thing over here. Okay, and I get 3.5, because half of 7 is 3.5 bicycles. But freeze right there. We are talking about, at this rate, how many bicycles will Samantha expect to see over 2.5 minutes? We can say that half a bike went through. That doesn't make sense. When we talk about bicycles, it has got to be the complete bicycle. Okay, it's just like you just can't cut up things like that and say 3.5 bikes went through. All right, it has to be the complete thing. So because we can't say half of a bicycle and which part is going through, what's going on, who's riding backwards, forwards, whatever. That's not how we write it. Okay, so we would say that in 2.5 minutes, okay, 3 bicycles, because that is the complete item. We can't just cut it up. So if you're given that, you would say 3 bicycles pass by in 2.5 minutes. Okay, no, please don't write 3.5 for bicycles. I'm trying to remove that glare. Ooh. Okay, that's better. All right, so for 2.5 minutes, we say 3 bicycles. All right, in 1 hour, so okay, let's write this again. In 3 hours, we had that 2.5 minutes. We had 3 bicycles. Okay, and over 2.5 minutes, I'm just writing it like this because I don't have space. And then in 1 day, so we know that in 1 hour, we had 84. Okay, so we had, let me erase this. So in 1 hour, we had 84 bicycles in 1 hour. So in 1 day, you know that we have 24 hours. We're going to assume that the same rate is going on, all right? Don't say that, you know, the day is only 12 hours, because guess what? It's actually 24 hours, okay? So we are going to take it as 24 hours, because that is what 1 day is. So 1 times 24 gives me 24. I do the same thing up here. Okay, 84 times 24, and I will get 2016 bicycles in 24 hours, which is 1 day. Okay, so this is how we calculate. Now let me show you, if you were to plot this in a coordinate graph, what you would do. Okay, we will go more in depth into coordinate graphing later on, but right now the basic where the graph paper should probably be provided to you at this point, but you've got to know the X and the Y axis and how to plot correctly, okay? So now we're just going to use this over here, and this is your Y axis, which is vertical, and then you have the X axis, which is horizontal. Okay, we're going to do this. This is 0. All right. The number of bicycles that are passing by depends on your time. Depends on your time. So your time, that is minutes, is your independent variable. We'll talk way more about this later on. Okay, between what's the difference between independent and dependent variable. The dependent variable actually depends on the independent variable. So how many minutes will determine how many bikes are going past that area. So that is why minutes is your independent variable, and independent variable always goes on the x-axis. Okay, so this is your x-axis, this is your y-axis. Okay, so I am going to take the minutes and write 5, 10, 15, 20, 25, and that's how much I have to plot, but let's say I have this. Okay, and then I am going to go ahead and I'm going to, let's say this is it doesn't have to be 5, 10, it can be 7, 14, and that's fine also if you want to do it that way. Or you can here's the thing, whatever my interval is, it has got to be the same here. Whatever the interval is, it has got to be the same up there too. So this is your time in minutes. Please label your graphs, because without labeling, you will have points deducted. It's very important to know what is on the x-axis. So what are you comparing with what? And what is on the y-axis is the number of bicycles. Okay, so I'm just going to label this just because I'm going to label this as 5, 10, 15, 20, 25, 30. Go up a little bit more. 35 and 40. This is how much I'm going right now. And I am going to plot till here because this is where the table had ended. Okay, so remember, X always comes before Y. Okay, you walk to the tree. You walk to the tree before you climb it. Don't start trying to be a monkey and climbing first. Okay, as human beings, we walk first, then we climb. All right, same thing. Think of the alphabet. X comes before Y. So you always look at the ordered pair in that way. So in 5 minutes, so you look at X first, we have 7 bicycles. So if this is 5, I know that 7 is going to be around here. Okay, so in 5 minutes, we have 7 bicycles. So this is 5, this is 7. Where they meet, that's where you put your ordered pair, and then you circle it so it can be visible. Okay, so here is my ordered pair, which is 5, 7. Just want to show you that. Okay, in 10 minutes, there are 14 bicycles. So this is 10 now, and this is 14 around over here. Where they meet, that is your ordered pair. Okay, 15 minutes, we have 21, which is around here. So this is your ordered pair. Okay, 20 minutes, again you go up, and we have 28, which is about here. And so this is where it meets. And then 25 minutes, and this is 35. So this is where it meets. So this is how they are meeting. You are seeing what the coordinate graphing looks like for this. And it becomes really easy for you to then connect the dots. And then you can just do this and it will go straight. Okay, now this is a linear function right now, and again, I don't want you to freak out just hearing that word. Linear just means it's a straight line. Okay, linear, and we'll go more in depth about this later. So in this indicator, again, you are filling the table, you are calculating what is asking over here based on the table. Okay, so you take those ratios and you use that to convert it, and then in the end you are going to graph it. Time is always going to be over here. Okay, the X factor, because it is an independent variable, and then the number of bicycles depends on how many how much time is being used, so that's the dependent variable. But what you need to know, a graph is very, very easy for you to see the visual. It's a visual representation of your data. And so that is why a graphing is so important in math. And you can immediately look at this graph and say, okay, 5 minutes, 7 bicycles, 10 minutes, 14 bicycles. So it becomes so visual what you are actually looking at. So this is a ratio representation in the form of a graph. It's a coordinate graph. And this is what ratio representation is all about. Okay, so this concludes your indicator 17. Have a nice day, guys.